Well, now let's take a look at multivariate analysis in Minitab. And we're going to use a particular data set to analyze this. It's called water. And what we see is there's a number of factors that deal with the purity of water. So the output measure, or the Y, is going to be purity, and these other factors are talking about how they influence the purity of that water. So, without any further ado, let's go into Minitab. There's sometimes when we want to have a discussion with process doers or operators, people working in the process, to get them to interpret our data. So typically, we have a situation where we have output data of varying quality, and we want to understand what they tell us is happening with various input measures. So what we have here is a data set. It's about analyzing purity of water testing. And what we see is there's different shifts that are operating. They have different sampling locations and different samples that they take. So those are called shift, piece, and position. And so as a result of that, we have varying degrees of purity. So what we would like to do is understand what's happening here. So this methodology was created by Dorian Shannon as a way of understanding where are the differences in order to have this discussion with operators to discover what they think is actually happening in the process when they're comparing best of the best and worst of the worst. So we see we can access this function under Stat. It's located under Quality Tools, and then we come down to Multi-Vari chart. So if I click on this, the response here is the percent purity, and we see that there are these three different factors, so shift, piece, and position. So if I double click on each one, and then if I take a look at options, I want to display the individual data points. Okay, so I click OK, and I get this output. Now, this output is a little difficult to understand. And so what I see is I have different pieces, so it's piece 1 and piece 2. So this is one sample, another sample. And then here are the different shifts. So this is shift 1 and shift 2. And then the different positions. So position 1, 2, 3, and 4. And so what I see here is I see a very big difference here by position as I go from position 1 to position 2. Here, the pieces don't make very much of a difference, but they do seem to have a difference. But notice that this is piece 2 with this little plus sign, so it's above, above, above. It's equal, now it's below, and now it's above, and it's above. So it's not always in the same direction. So that's one question we might want to ask the operators, what's actually happening with that? But we see the biggest difference appears to be in the different positions, okay? As we take a look at the average across the 4 panels, that's this green line here, we see it's pretty flat. It says there's not much of a difference in the averages. So the question we have for the operators then is what's happening? Now, I want to give you a couple of cautions about using this. We're very lucky in terms of the graphical output that we got. But let me show you what happens if I edit the last dialog box. Okay, so I edit last dialog box. And now I'm going to change the order in which I've entered them. So I'm going to put piece in, then I'm going to put position, and then shift. So all I've done is I'm looking at the same factors, but I'm going to see them in a different way. And now see what happens. Oh, okay, so the position variables are here. So 1, 2, 3, 4, 1, 2, 3, 4. Pieces are in these panels here. So this is 1 and 2. And then these positions, if you will, I can't see the difference. Look at this. So as I'm taking a look, I start seeing it's getting confusing. It's not as clear. Let's take a look again. Edit the last dialog box, and I'm going to shift it one more time. And now what I'm going to do is I'm going to change this, and I'm going to put in here position, and then shift as a second one, and piece as a third. Whoa! Now you see the difference. I'm just getting a graphical summary. It's plotting the averages of a very small sample size. And so as I'm looking at this, it's very hard to see what the difference is. So here I see there's piece-to-piece variation. Okay, I can even see this group is sort of lower than this group here. except for that one and that one, but this would all be true. Okay, so what's actually happening here? So if I go to stat ANOVA, you as a green belt can take a look at this and say, okay, let's do what's called a balanced ANOVA. So here I take a look at purity, and here I take a look at shift, piece, and position. And as I take a look at this, what I will see is I have an ANOVA result out. Okay, and here I see in the ANOVA for shift, piece, and position, the p-value, the only thing that's significant is the piece-to-piece variation. So this is the mathematical proof that says that is the true factor that's important. And if then I take a look at these graphs and I see the multi-vari chart, and I say, okay, so piece-to-piece variation is significant, I can see it here, okay? It's raising some questions about these others. So this flat line, I can say it's not really different. But then what's happening in terms of shift to shift? Is there some difference? And why is there inconsistency among the shifts in different places where they take the data? I can take a look then at the multivariate chart by piece. And I say, okay, here I see, okay, what's happening here? So there's the piece-to-piece variation, okay? And now I can say, okay, I can see this other thing, but it looks a little confusing. So it's not necessarily a good picture to show to the workers in the process. Now if I take a look at this by shift, I say, okay, what am I saying? Here's the piece-to-piece variation, okay? And there's the position variation, and I don't see any difference in here really, and I don't see the difference there. So which one of those three is the one you would like to discuss with the operators? So this is something you should do before you go talk to the workers, to understand which of the graphical ways you want to show and talk about so that they will have the clearest understanding and be able to have a good conversation. Remember, the multi-vari chart is about the conversation you have with the operators to pull out of them some of the knowledge they may not have articulated or thought about, and to get them involved in the process of analysis as team members. Now that we've looked at this, I think you'll see the value of this particular methodology as well as the care with which it must be used. We have to be very careful to pre-analyze the data. Maybe we want to use an ANOVA first to understand what's really is the data telling us, what things are statistically important. Because the different order that we input the data into this water file, we see gives us very different interpretations. Some can be confusing, that don't really tell us what we need to know. So before you go public, if you will, with the analysis of this multi-vari analysis to get people involved in discussing the data set, it's best to go through and analyze and figure out what's the best combination or ways to actually show the data to have that conversation. So now let's take a look at what happens when we actually do this with a mathematical analysis like in ANOVA.